Hello students. So in the previous class, we derived an expression for the electrolyte concentration cell with transference, and we derived what is the EMF of that electrolyte concentration cell with the transference. So we got E, which is equal to 2.303 T plus RT by F, RT by F log A2 by A1, log A2 by A1. So this is the expression that we got for the EMF of the cell, which is now electrolyte concentration cell with transference. So 2.303 3 plus RT by F log A2 by A1. So where T plus is the transport number, transference number of cation, and all others are constant. A2, A1 are the activity of the solution 2 and 1 respectively. So now let us know express the equation. This cell EMF of the cell you can express through in terms of activity coefficients. So or no, activity coefficient we already expressed. So let us discuss in terms of mean ionic activity. We know activity of an electrolyte. Now generally if you say activity of HCl, it will be equal to activity of cation into activity of anion. So this is the expression that we have. So generally you can represent activity of cation and into activity of anion. That is nothing but A plus or minus. So this is mean ionic activity. Mean ionic activity. So let us now express the equation in terms of mean ionic activity. So what you will get E cell, which is equal to, now if you avoid not 2.3 not 3, you can express this equation in terms of Ln. So let us express in that way. It will be T plus RT by F Ln. Now A2 by A1, instead of A2 I am expressing A plus or minus 2 divided by A plus or minus 1, where A plus minus is the mean ionic activity. So we express the equation in terms of mean ionic activity. So this is, sorry, it's not T plus, I'm sorry, it's not T plus, it's T minus. It's T minus. Please correct it. EMF of the cell is equal to 2.3033 minus RT by F log A2 by A1. This is the equation of the EMF of the cell where electrolyte concentration cell with transference. So please correct it. It is now E cell which is equal to T minus RT by F ln A plus O minus 2 divided by A plus O minus 1. So here now one more point is there. Here now A plus or minus, A plus into A minus is equal to A plus or minus square. Sorry, A plus or minus square, which means now if you express this will be A plus or minus 2 divided by A plus or minus 1 the whole square. So 2 will come. That means now if you express now this ln part, this 2 square will come here. So you will get E cell which is equal to 2t minus RT by F ln A plus or minus 2 divided by A plus or minus 1. So that's an expression that you're going to get. E cell which is equal to 2t minus RT by F ln A plus or minus 2 divided by A plus or minus 1. Where now A plus or minus is the mean ionic activity and T minus is the transport number of anion. So please check that, and this is the final equation that we have. Now this is the case now we discuss hydrogen electrode where now electrode is reversible with respect to cation. Now let us discuss another case where now this time this is a cell in which no electrodes are reversible with respect to anion. For example, silver electrode that we now discussed already before, AgCl in HCl solution, aqueous A1, which is separated by another solution having different concentration. HCl concentration is A2, AgCl and Ag. So these are two electrode in which no electrolyte having different concentration, where we have taken A1 is greater than A2. The concentration of A1 is greater than A2. So this is silver electrode actually. No, it's a electrode which is reversible with respect to anion. So here you will see, no, what's the difference here? HCl concentration, you can see both are different concentration. So what is the EM of the cell that you can obtain from this? No, this is the case where electrolytes are allowed to pass through from one solution to other. So this is a electrolyte concentration cell with transference. So let us try to derive, because now we already derived an equation for the EM of the cell in which no electrolyte is reversible, electrolyte concentration cell with transference. So this is the difference where no here electrode is actually reversible with respect to anion. So let us express the anode reaction of this particular electrode. Anode will be silver undergo oxidation. Silver actually combining with the silver ion to form silver chloride, and electron will be released because it's an anode reaction, so oxidation. Similarly, at cathode, this AgCl actually combined with the electron to get Ag plus Cl minus. So here Cl minus is in a concentration A1, here Cl minus concentration will be A2. So this is the difference. This silver electrode in which electrodes are reversible with respect to anion. So overall reaction you will see everything will cancel. What is left is Cl minus aqueous A1 transfers to Cl minus aqueous A2. So just like Cl minus concentration of Cl minus is higher in so Cl minus actually moving to A from A1 to A2. So that's the only difference. Now let us try to think this is an electrolyte concentration cell with transference, which means you imagine Cl minus concentration is less, is going to decrease at the anode because it's consuming at anode, and the Cl minus concentration will be higher at cathode. So which means Cl minus concentration is less, means H plus ion concentration will be higher at anode. So H plus ion will be moving from anode to cathode. So you can express H plus, that is if similar way that we express derive the expression, we can derive here. If 1 farad electricity is passed through the solution, then T plus is the transport number of H plus ion. So T plus H plus ion from A1 to moves to T plus H plus ion to A2. So this is just like H plus ion having a transport number T plus is moving from A1 to A2. Now, if H plus ion moving across from A1 to A2 means what about Cl minus? Here you can see Cl minus will be excess at solution 2. So Cl minus will be moved from A2 to A1. So you can, if T minus, let T minus is the transport number of Cl minus, then 1 minus T plus will be the transport number of Cl minus. So you can represent 1 minus T plus, which is actually nothing but T minus. So 1 minus T minus Cl minus is moving from A2 to A1. 1 minus t plus a1. So that's the final expression that we got. So these are the no transference that is taking place in this particular electrode. Now what you need to do is just sum up everything. You sum left hand side and right hand side. You will get Cl minus A1 plus T plus H plus A1 plus, well, you just now expand it, 1 minus T plus into Cl minus, so it will be Cl minus A2 minus T plus Cl minus A2 gives, here now right hand side what will come, here will be Cl minus A2 plus T plus H plus A2 plus, now 1 minus T plus into Cl minus means no Cl minus A1 plus here minus T plus Cl minus A1. So this is what we got. So now let us cancel the common term. What are the common terms here now? Cl minus A1 is here also Cl minus A1 is there, so let us cancel Cl minus A1, Cl minus A1, and T plus H plus A1 is there, and here T plus, here T plus Cl minus A1 is there, so let us take this to this side, so you will get T plus H plus A1 plus, I taken this to this side, so it will be T plus Cl minus A1. Now rest, now you can see here Cl minus A2 is there, Cl minus A2 is there, so that will cancel. So gives, here what is left, here minus T plus Cl minus A2 you can take to that side. So here T plus H plus A2 is there, so it will be T plus H plus A2 plus, I am taking this to this side, so T plus Cl minus A2. So literally now equation now become like this, T plus H plus A1 plus T plus Cl minus A1 gives T plus H plus A2 plus T plus Cl minus A2. So now how can you modify? This is simply like no, you can write T plus HCl A1 gives T plus HCl A2. So here now remember in this particular now electrode we consider A1 is greater than A2. So just like now A1 from higher concentration to lower concentration, the electrolyte are moving. So that part now final expression you can understand. So this is the what we got. Now let us apply the nearest equation. You will get E cell which is equal to E0 cell. Since now hydrogen electron it will be 0, so it will be minus 2.303 RT by F log, here now right hand side it will be now A2 T plus raised to A2 means you can write now T plus will be at the upper side, so T A2 by A1 raised to T plus. Similar way we derived the previous equation, right? So you can simply write like this. So E cell will be equal to, you can change the minus sign by reversing this, so it will be T plus 2.303 RT by F log A1 by A2 log A1 by A2. So here now remember A1 is greater than A2, so you will get a positive sign. or now you can still now avoid log if you want to express through ln, and now you can express in terms of mean ionic activity. So let us have a now simple equation. So you can write E cell will be equal to T plus. So here now if you express in terms of mean ionic activity, you can write T plus into 2 will be there, because no a1 you can express as a plus or minus 2. So like that now it 2 will come. So 2 plus T plus 2 into RT by F ln a1 a plus or minus 1 divided by a plus or minus 2. So this is the way we express in terms of mean ionic activity, a plus or minus 1 by a plus or minus 2. So from where 2 comes, because now this power will be there, so that we taken here. So ln something of power will come to here. So t plus into 2 into RT divided by F ln A plus or minus 1 by plus or minus 2. So this is the case now where electrode are reversible with respect to anion. So that's all for the electrolyte concentration cell with transference. Now let us discuss what is liquid junction potential is all about. Liquid junction potential. So liquid junction potential means yes, you imagine two half cells in which two electrolytes are allowed to mix each other. Two electrodes are allowed to intermix each other. You will see the ions are moving from one solution to other. So that actually the movement of ions in that particular junction between the two solution actually creates a potential. That potential, the potential which is developed at the junction of two solutions due to the transference of ions in a electrolyte concentration cell, that particular potential we will call liquid junction potential. Just symbolically, if you want to express, you consider a two half cells is there where the junction will be a porous membrane. You imagine where ions are allowed to travel. Now let it be HCl, be the electrolyte, where HCl concentration is higher. You imagine it's higher here and it is lower here. Then you will see if this junction is in such a manner, here H plus ion will be moves to A2, because here concentration of A1 I am considering is greater. So H plus ion, which is smaller ion, will move faster compared to Cl minus ion. So similarly, a Cl minus ion which will be moved from this A2 to A1. So literally what you will observe here two junctions are separated by a thin membrane where ions are allowed to transfer, where you will see these fast moving ions, smaller ions moving from higher concentration to lower concentration, which means this particular solution will be more positively charged, because this solution will be more with a plus ion, where here H plus ion moves slower, which means this will be positive, right? Similarly, Cl minus ion move from A2 to A1. So here you will see this will be negatively charged, or here H plus ion more moving means Cl minus will be higher here. So this is the case. A potential difference is developed. One become positively charged, another become another become negatively charged. Here, if the A1 is greater, means this is concentrated solution, this is dilute solution, if you imagine. So concentrated solution becoming actually negatively charged because no fast moving smaller H plus ion moving to E2. So that's the way, because of the movement of ion at the junction develops a potential that we will call liquid junction potential. This is the case, you will observe in with electrolyte concentration cell with transference. Now let us now have an expression for the liquid junction potential. So just imagine how now remember this liquid junction potential creating a potential which actually affect the actual EMF of the cell. If you now think about a cell, we know normally we getting a EMF of the cell due to the electrode reaction at anode and cathode. But here in the liquid junction there is a potential is also developing that actually contributing to the actual EMF of the cell. So this is the case where now you actually getting a EMF including the liquid junction potential. So how can you now have an expression for liquid junction potential? So this is the case where now you can imagine an electrolyte concentration cell without transference and with transference. So both we have an equation for a hydrogen electrode. If you imagine platinum hydrogen gas, where hydrogen gas is kept at 1 bar pressure, HCl E2, hydrogen 1 bar, platinum. So this is the case now hydrogen electrode in which this HCl having concentration A1, HCl having concentration A2. So this is the case we discussing the electrolyte concentration cell with transference. So we already have an expression for this. It is 2T minus RT by F ln A plus or minus 2 divided by A plus or minus 1. So this is the case where A2 is greater than A1. So this is the expression we already derived before. So this will be with transference 2T minus RT by F ln A plus or minus 2 divided by A plus or minus 1. So here you will see in a contribution from liquid junction will be there. So similar case where now if you take platinum hydrogen gas 1 bar pressure HCl A1. Now we separating through a salt bridge, which means a direct transfer of electrolyte are not allowed. In such cases, what will happen? Here liquid junction potential is not there. So this is a similar case where the electrolytes are not allowed to intermix each other at the junction. So where now we generally use salt bridge. So this is the case where electrolyte concentration cell without transference. So let's have an expression E without transference. We already derived the expression. It will be just like RT by F RT by F ln A plus or minus 2 divided by A plus or minus 1. So this is the expression we have. Electrolyte concentration without transference. Here electrolyte concentration cell with transference. So now let us have an expression for liquid junction potential. E liquid junction potential. So what will be? So this is literally the a liquid junction expression you can easily derive from the E with transference minus E without transference, which actually the liquid junction potential, because no other difference. Here ions are allowed to travel in with transference. Here ions are not allowed to travel through a direct contact is not there. So which means the liquid junction potential will be E with transference minus E without transference. E with transference minus E without without transference. So just minus this, you will get no. Here, what is common? RT by F ln a plus or minus 2 divided by plus or minus 1 is the common term. So 2t minus here now nothing is there. So let us minus it. You will get 2t minus 1 into RT by F ln a plus or minus 2 divided by plus or minus 1. So this is the expression we have for the liquid junction potential. Liquid junction potential. Now we know summation of transport number will be always equal to 1. So let us know instead of 1 you can apply t plus t minus. So if you apply minus t plus t minus means 2t minus t minus will be equal to t minus. Right. So you have E liquid junction which is equal to will be equal to t minus t plus into RT by F ln a plus or minus 2 divided by a plus or minus 1. T minus minus t plus into RT by F ln a plus or minus 2 divided by plus or minus 1. So this is the expression that we have for the, let me write it cleanly. So E liquid junction potential that we got T minus T plus into RT by F ln a plus or minus 2 divided by plus or minus 1. So this is the final expression that we have for the liquid junction potential. Now think how the liquid junction potential will develop. If T minus is greater than T plus. This is the case where no transport number of anion is greater than transport number of cation. In such cases, you will see liquid junction potential will be positive. So the total EMF of the cell will be more than the actual EMF due to the contribution of liquid junction. So you can see liquid junction potential actually depend on the transport number of cation and anion. Just a key point you can remember. So here ELG liquid junction potential will be positive. Now if T minus is no less than T plus, so in that case this will be negative. So E liquid junction potential will be negative in this case. So total EMF will be will be less than the actual EMF. So you are actually getting a lesser EMF due to the transport number of cation is higher. If you think HCl where H plus ion having higher transport number. So in such cases you are actually getting a total EMF will be actually less than the actual EMF. Because now T plus is greater means you are getting a negative liquid junction potential. Now in the case where T plus is equal to T minus, that's the case you will get E with transference will be equal to E without transference. Right. So because in that case you are actually getting E liquid junction potential. E liquid junction potential will be equal to 0 because here you will see T plus T minus 0 means the whole term will be cancelled. So in such cases you are actually getting an EMF which is which will be the actual EMF or there is no contribution from the liquid junction potential. So that's the case. So we want a junction between the two solution if the junction having a similar transport number of cation and anion, if it is equal, then you can eliminate liquid junction. So that's the key point I'm coming to say. So if the junction separating between the two solution is in such a manner, if the transport number of cation and anion are equal, you can simply eliminate liquid junction potential. That why we using a salt bridge to separate the two half cells. There now inside we generally taking a electrolyte like K plus KCl, where K plus Cl minus having similar transport number. So if the two half cells are separated by a electrolyte like KCl, which having similar cation and similar transport number, similar transport number for K plus and Cl minus means transport number of K plus will be equal to transport number of Cl minus, which means you can avoid liquid junction potential. So what salt bridge is doing? It actually eliminating the liquid junction potential. So we have to take a electrolyte now which having similar transport number. If that is taken, then liquid junction potential can be avoided. If no salt bridge is not used, you can see liquid junction potential also playing a important role, which actually interfering the actual EMF. So this is the liquid junction potential that is developing now when the two electrolytes are allowed to mix each other. Then you will see a potential will be developed at the junction that we will call liquid junction potential. So that's all for today. So now let us discuss one more point. Let us wind up, because now we have an expression for EM of the cell with transference and EM of the cell without transference, that we already written, right? So E with transference divided by E without transference will be equal to 2T minus. Please remember that now we already have an equation E with transference and without transference. So with transference will be equal to 2T minus into E without transference. So just remember that, because in calculation purpose you need. This is when you take the ratio E with transference divided by E without transference will be equal to 2T minus. You can remember that. So thanks for listening. Let us find out. Thank you.